What we've got right here behind me is a Suzuki DF200 lower unit. Now the same lower unit is used on the DF150 and 175 and of course this 200. And for whatever reason, a lot of these seem to be failing. If there's somebody at Suzuki that can explain this to me, get in contact because this is weird. Let me show you what's going on with these. This year alone, I believe I'm on my 7th? Something like that? 7? A whole mess of these. I mean, every one of them, the pinion gear is just falling apart. This one literally snapped in half. Now, the weird part about that is, if you look at where the fracture is, it goes through the thickest part of this gear tooth. And then just like right straight down, it doesn't make sense to me the way that these gears are failing. It looks like some sort of factory defect to me, like they didn't get hardened properly. There is some sort of material issue here because no other brand has been doing this. This has only been this Suzuki lower, which is the 150, the 175, and the 200. We've seen so many of these things, and now maybe people are hitting stuff, but the props aren't bent. I mean, I've already pulled the prop off this. It's an aluminum prop, and like, it's fine. There's not any witness marks, no nothing to indicate that anything has impacted this lower. But with that being said, this one's got a bad pinion gear as well. So I'm going to show you the process of essentially rebuilding the Suzuki lower unit. Now, you do need some special tools for this. All that stuff's going to be linked down in the description. I'm not going to go through and show you everything right now because I've probably forgotten half the things that I need, and I'm going to have to go over and get them out of the toolbox. But let's get started and get this thing torn apart. We've got this lower all disassembled, cleaned out, so as many metal shavings as we could get out are out. You're going to want to run this through a parts washer as much as you can. Try and get the shavings out like we have, and then we're going to reassemble. Now, obviously, after it goes back on the boat and we run it for a while, we'll want to do an oil change on it, but that's down the line. When you're starting reassembly, you want to pay close attention to your old gear. This one has on one of these clutch teeth 0.05, minus 0.05, and our new gear has plus 0.05. So that's talking about the shim thickness. Now, there's a number of different shims that go in this for each different gear in each different direction. And there's a whole chart in the service manual about that. The big thing that's important is don't trust what's on the gears. Use yourself some sort of caliper set. Measure the shim that's in your lower. Don't just assume if your gear says negative 0.05 and your new one says negative 0.05, you may still not have the right shim. What I have seen happen on a number of these is the gear has a spec for how much more or less shim it needs, and the standard size shim is in there. So that could throw off your backlash setting on your gears and could cause things similar to these failures. So don't know if people are just slapping them together, trying to get them out with COVID and everything, wanted to get as many done as they could, or what, I don't know. But we're going to put this back together. I've selected the shims that I want. Keep in mind, even if you select the shims that are shown exactly on your new gear set, it still may be wrong. You're going to have to put the gear in, put stuff together a bit, check the backlash, and you may have to take it all back apart to adjust it. So, next step for us at this point, though, is reinstalling our needle bearings. Now, I've made a wonderful little soup here of needle bearings and a high moly content EP grease. This grease is something that I use. It works good as a glue to stick the needle bearings in place in there so that I can slide the gear in without having to worry about the logistics of losing these things. Because if you lose one in here, you'll have to shake it all around and get a magnet and all kinds of stuff to fuss and find and get that thing back out. So glue them in place with a little bit of grease. Let's put these things in. There are, as a note, 35 of these small shims for the forward gear. So count yours before you assemble it. 35. You need 35. Let's put them in. Use some of this leftover grease to glue our shims into place as well. We've got our forward gear all in, shimmed and in place. We're getting ready to put our pinion gear and drive shaft back in, and I thought I would show you this because this could be a little tidbit that may be related to why so many of these are failing. The old pinion gear, this destroyed thing, has a marking on it minus 0.05. Now, the pinion gear backup shim, that's this guy that goes up here, should be a 1 millimeter, is the standardized spec. So with that pinion gear saying minus 0.05, means it's going to be 5/100ths of a millimeter smaller. So it should be a 0.95 millimeter shim, right? If we take our caliper here and measure this shim, we get 0.75, approximately 0.74. So that is a minus 0.25 millimeter, which is way off. That is an enormous difference. And our new gear says minus 0.15. So this should have a 0.85 millimeter shim, which I have located here, 0.84. So if my calipers may be off by a hundredth of a millimeter there, but so this is a 0.85 shim, and I believe it actually says on it, it has a number printed somewhere. Yeah. So this is the shim we need for the new gear. Now, perhaps my initial statement saying that there was some factory defect with the gears, that they were not hard enough or something like that, a material defect, maybe it's not that. Maybe it's just that the technicians that are assembling them are using the wrong shims. So I know with some companies, they will pay technicians on a commission or like a job completed type basis, which in my opinion is just asking for problems, because everything goes out the window for speed, because the more jobs you can crank through, the more you get paid. So they're just going to slap them together with whatever they have at hand. Now, that's obviously not how I work. I'm putting this together with the right shims. So let's put this together, and same thing with the drive shaft. Has these little needle bearings. I do the same thing with the grease and stick them up in one at a time until they're all in there. And there are 28 of these, I believe. 28? I don't know. I'll put it on the screen how many of these there are, because I counted them and then I put grease on them, and I don't want to count them again right now. So I'll count them, so I put them in and put it on the screen for you right here. Right here. This is how many of these there is. All right, let's put these things in. This is a new nut and our washer. We're going to reinstall our drive shaft or prop shaft now. And so it's got a spacer up here in the front. Shift assembly. We replaced the spring already on here that got damaged. There's another shim here that we may have to adjust, but we're going to put this back in. That. Then we can put our shifter assembly back in. Again, this is all stuff that should be cleaned off as much as possible. These magnets are tough to get clean, but get them the best you can, and we'll be flushing the fluid several times anyways. Yeah, but that back down in. Now, our bearing carrier assembly here, we pull this reverse gear off again, parts washer, but there's a shim on this gear, needs to be pulled off. So we'll inspect what this is, and these will almost always have to be changed. The one that I showed you on the back of this shaft, and this one will almost always have to be changed with a new gear set, because this is going to set the prop shaft play as well as the position of this gear. And seeing as we changed other shims in there, it's pretty much essential that this is going to have to move forward or back a little bit. Okay, so we've got our bearing carrier here, which also holds our rear gear. And this bearing, despite this being called the bearing carrier, this bearing does not bearing. Normally an inner and outer race should be separate. This should be able to be spun, but yeah, this one isn't. So we're going to replace this bearing. Now, in order to do that, I've got this set up on a vise where the jaws are far enough apart that I'm supporting this, but not the bearing. And I can get a punch down in here because I'm not worried about damaging this bearing. And essentially, I'm just going to alternate from side to side until I drive this bearing out of here. Like that. Take a look at this bearing. Doesn't look that bad, but it doesn't really do that whole turning thing that bearings are supposed to do. So we've got new bearings. We've got some Timkins. Now, Suzuki likes to charge a lot for these bearings, but they are a common size, so you can just pick up a bearing that matches the spec. These Timkins match the spec. They fit every criteria except these are sealed, and we want open bearings. So let me show you how we are going to convert this sealed bearing into an open bearing. So this little ring here, essentially just have to get down under that with a screwdriver and right up out. Now we can flip this over. Do the same thing again. And there's our dust shields off. And look at that. Open bearing that's nice and easy to turn. So we'll wipe some of this grease out, although it doesn't really matter if there's a little grease left in it. And then we'll press it into our bearing carrier. We've got our bearing carrier all cleaned out now. Our new Timken bearing ready to go in. But we need to be cautious not to put pressure on this inner race. We want to press on the outer race. And so to do that, I've got this, which is designed as a bearing driver. So if you look here, got this set, bearing race and seal driver set. So just pick one out that fits the outer race nicely. Then we're just going to put this in the press. Starts down in. Let's put just a little bit of pressure on it. I should probably say this with an accent, being that we're using a hydraulic press on YouTube, but I can't do that accent very good. So those guys are awesome though. Just put a little pressure on this. And there it is. Ready to go back on the lower unit. So let's haul all this back over and reassemble it now that we have a bearing that spins nice and easy compared to the other one. So let's head back over there. So with our new bearing in here, our reverse gear just kind of slides into this. It's not really a press fit. It will come in and out relatively easily. That's ready to go. We've got our shims selected for here, shims selected for there. There's a whole process on setting the proper backlash, the end play on the shaft, and everything along those lines. But that could take hours to explain, so we're going to leave that to look at the service manual and follow the instructions. At this point, with those selected, up is marked on our bearing carrier. We're going to push this in. Now our O-ring may catch a little bit, so as we slide this in, we'll kind of wiggle this a little bit and get that to slide right on in there. O-ring was a little stiff. It's a little chilly today, so not surprised. Put our bolts in here. If you follow the directions successfully, you will have the correct amount of backlash and the correct amount of end play. So, with that being done, we can test and see that we're not binding in neutral. We have forward and we have reverse. And everything seems to be working happily. So I'm really curious if some of these got set up wrong at the factory, finding that some of the shims didn't really seem to follow the instructions that are in the service manual. Don't know if all of these got made on a Friday at 4:45 p.m. or what, but I've seen an awful lot of these that have failed in the same exact way, and maybe this was the answer to it. Maybe they've been shimmed wrong from the very beginning. Either way, regardless of what caused these failures, we're going to put some oil in this unit, get our prop back on, get our water pump back on up here, put this thing back on the boat, take this back to the customer so that they can keep using their boat. That's pretty much all there is to rebuilding one of these, though. Sure, I didn't cover everything, and I know there's going to be something somebody's going to say that I missed or forgot or didn't point out, and that's why it's very important. Follow the service manual procedure. This is a vague idea so that you can see somewhat how some of the pieces go together, how they interact. Not really a complete guide, but will get you on the right track with the right process in the right order as long as you follow the service manual along with this video to do the exact detail measurements, the things like shimming and setting the backlash, how the gears have to mesh. You don't want them too high, too low, it all has to be set up right. Otherwise it could prematurely fail, which is exactly what all these were doing, which makes me think this has been a problem all along. And hopefully, like all the others that I've rebuilt, this one does not fail anytime soon. So, hopefully this was useful to you if you've got a Suzuki lower unit that's blown up on you. Get in touch, let me know, because I'd be curious to know if this is an isolated problem, if just all of them that I'm seeing are blowing up, or if this is a problem across the board that something should be recalled or along those lines. Anyways, thanks for watching, and I hope you'll tune in to our next video that we have.